Hi, I'm Manjiri, and I have done this big data analytics final project with Paresh. We have basically done the active sentiment analysis and calculations for the live portfolio. So, so to give you an overview, basically. Rebalancing of a large set of portfolios is scheduled periodic activity that large teams and in-house products are constructed around. Running these in batches is typically how this is done and in some cases unavoidable. So any change in position or the market has an impact on the investment portfolio. Understanding its impact requires that the metrics that people are interested needs to be recalculated. As the size of the portfolio and the number of portfolios affected grows, the number of operations that a technology providing platform needs to be performed to keep growing. So basically doing these in real time and using the same operation to run scenarios as for the batch processing allows for more nimble strategies and more confidence in performing actions. Now, one of the advantage of doing this real time would be detecting early signals gives the product holder a competitive advantage in rebalancing his holdings. Now, as we remember from class that using big data technologies is useful in allowing the handling of high velocity and high volume data. So basically, big data is high volume, high velocity, and high variety information assets that demand cost effective, innovative forms of information processing for enhanced insight and decision making. So, in order to basically use these components of big data, so we have built a live ticking UI and compute platform using open source software and commodity infrastructures to handle the three V's of big data analytics. Now, the single calculation platform that runs operations in parallel on high volume information such as transactional and market data and news feeds for all hosted portfolios and user accounts. Uh, this ingests high velocity data such as Twitter feeds or trader market data. We use the Yahoo market data and emits delta notification keyed for targeting peers with registered interests. Events are routed to a live grid, which is written in AngularJS, capable of ticking data exchanges and flexible enough to dynamically add data points to its columnar layout. And we also use a custom model for classifying high variety micro batches of tweets and adjusting component weights based on whether a holding is driving a wider sentiment, bucking it, or will it be affected by wider section or market which it belongs to. Now, Parish will give an overview of the technology stack and explain the design and flow.
Thank you, Manjari. So, um, the guiding principle behind the technologies that were chosen were to let the logic be pluggable. So the logic here really is the calculators that are written by us for the standard metrics and formulas that people would be interested in, but also anything that others would come up with themselves, saying this is what will give us a competitive advantage, this is what I think would be useful to track, or this is what I think I would like to calculate. And so we wanted to let people be able to track their portfolio live, and customize the information that they would be able to access, but also let them run scenarios, run some research, and use a large compute engine to run this in parallelize it. The technologies that were chosen were Spark Streaming, um, Kafka, and Angular UI and Vertex for the front end. And the model and the classification algorithms were Stanford NLP's classification algorithm with our own weightage for sentiment scoring, which we will explain a bit later. So moving on to each of these components. Um, high level, this is how the entire platform and all the pieces fit together. So as you can see, the backbone of the entire solution, the entire application is Kafka. That's where all of the trades and market data feeds come in. That's where high speed and high volume data can easily be pushed in. Now, as you can see here, there are multiple nodes that are configured for the Kafka cluster. Um, Kafka automatically is able to communicate and distribute its messages, and Spark works very well with Kafka. Spark streaming um, is able to read the data off of Kafka in small micro batches, and it also has adapters for reading streams from Twitter. Um, the arrows as the arrows here actually indicate the flow of information. So both Kafka and Twitter information gets ingested into Spark, but the output from Spark also goes right back onto Kafka, um, because that really is the best mechanism for distributing information across all the components. Vertex is the piece that ties everything together. That's where all of the logic runs, and that um, has a Kafka consumer built in, written in it, which holds on to each of the WebSocket peers. So that's the front end. That's the other end of this platform, which is a browser and a UI opening up a WebSocket connection, registering interest in push notifications, and the Kafka consumer running inside Vertex keeps track of all of these WebSocket peers, and they're all keyed off of accounts and all the holdings, and Vertex's Kafka consumer uh, gets gets the deltas from Spark via Kafka and sends the notifications out to the registered peers um, via WebSocket notifications. Um, this high level kind of goes over what we just discussed. The idea was to let every piece, every component be pluggable, but also the ability to be able to horizontally scale every component. And so every piece was written with the idea that minimal changes would have to be needed to add a formula, add a calculator, add a column. Um, so the main backbone, the backend, the Spark and Kafka combination, they are really completely agnostic to the data that's flowing through them or the calculations that are running in them. And the same goes for the UI, which is the Angular UI grid, which automatically detects the schema that it's getting and paints the grid for the user. Um, the some of these some of these points are talking about how well Spark works with Twitter and Kafka, and also how easily Kafka can handle high volume data flowing through it. Um, the interesting things about Spark are its ability to join data in its parallelized distributed data sets, and Vertex's ability to support push notifications and also be able to run multiple JVM languages in it. So digging a bit deeper into each of the components, Spark streaming is actually two parts. One is the Spark engine itself, which takes care of parallelizing your logic and shipping data off to each node so that the logic can run on separate batches. And Spark streaming kind of bridges the gap between the resilient datasets, the RDDs that Spark runs, and the streaming engines that provide this data. So Kafka plays very well with Spark streaming because it gives the adapter the ability to replay messages in case of failure, which is one of the big advantages and one of the big improvements of Spark over for example, Hadoop's MapReduce, because instead of replaying the entire job, it's able to replay micro batches. Um, this high level gives an idea of what Kafka's topology looks like. So as you can see here, multiple brokers talk to each other via a zookeeper coordinator, but each producer can be publishing messages to more than one broker at a time, based on how the data is partitioned. And each cluster automatically keeps a quorum, so it's able to recover from a loss of a single node. And also, multiple brokers can be added if there is ever a need, for example, for multiple Spark executors to be brought up, and more data to have to be pushed through. Um, that kind of wraps up the back end, the infrastructure part of this uh, application. The front end really, um, the interesting part here is the choice of the framework that we've used. So as you can see here, Angular is very well modularized. It naturally supports dependency injection and supports callback functions. So it's able to register WebSocket handler as a single function, and the handling of the data updates is really simplified because of the way Angular UI grid works. This is all it takes for the HTML markup to identify what the grid should look like. And just by inspecting the schema of the JSON that's coming through, Angular UI Grid is able to paint the entire dashboard, and it comes with capabilities for filtering, sorting, and grouping, and so on. And also, it gives the ability to tick individual columns in the grid. Which brings us to the framework that binds all this together. Vertex is very flexible framework that does more than just what an application server used to do. It it really, one of its strong points is the ability to build microservices. But it the other interesting thing about it is that it is a polyglot framework, which lets us run our Scala calculators on our code inside Vertex. It also lets us run our Kafka consumers, which actually have more powerful APIs in the Scala language right now. Um, the vertical is, as you can see here, is written in Java, and the JavaScript functions here, uh, shown here, are what's taking care of pushing the Delta notifications onto the UI. So lastly, the classification that was run, the sentiment analysis that was done on Twitter feeds. Um, this slide is just a bit of a background on the APIs that Twitter provides. Twitter gives us the um, ability to either query or subscribe for push notifications, but the query API is limited, and we obviously wanted to get continuous feeds from Twitter, so we went with Spark's already built-in adapter for Twitter streaming. As you can see here, we've used Stanford Core NLP's recursive neural network model for classification, and this model gives a sentiment score of 1 through 5, with 3 being neutral, and the higher the score, the more positive the sentiment classification is. What we've done here is, often a product is getting uh, pushed up simply because of the asset class, or because of the industry that's in, or because the market itself is doing well. And it's we thought it was useful to be able to identify products that are leading the market and weigh them accordingly, and also products that are doing worse than what the other peers in that industry and in the market are doing, which would be something that people would want to react to right away. So as you can see here, we've put weights against an individual product doing um, differently than the higher the bigger picture itself. So that wraps up the internals of what the application does. And back to Manjari for a summary.
Yeah. I'll start with explaining the testing performed and the results. The entire functionality, including the live ticking UI, Kafka infrastructure, calculators running inside Spark streaming, and the streaming Twitter sentiment analysis was tested end to end. The Vertex package was started up and the Angular grid was viewed in the browser with a prominent alert to indicate that the UI had opened a subscription for push notifications. Trades were played onto Kafka ECN topic to simulate transactions ingested from the trading exchanges. Market data ticks were periodically played onto the MDS topic to simulate price feeds from sources such as Yahoo Market Data. The Twitter sentiment calculator was subscribed for health products with a short refresh window. Now, the success criteria for each played event was that the calculated results tick on the UI in a few seconds. In all our runs, success criteria was met. Um, so, as a conclusion, the live ticker which we have developed works on similar lines as some of the new companies in the fintech space like Wealthfront and Betterment use their own algorithms to automatically rebalance the holdings based on guidelines provided. So using big data analytic technologies like Spark, Streaming, Kafka, and their ecosystem lets us build a platform that is real-time, extensible in the calculations and metrics that can be plugged in seamlessly and flexible in the nodes that it offers, such as the ability to run scenarios for research purposes and the real-time dashboard mode that lets you monitor your holdings and gives you the competitive edge of being able to handle high velocity, high volume, and high variety data with ease. Um, that concludes our presentation, and thanks to Professor Lin and all the TAs.